understanding a structure composed of diverse elements arranged in a pattern, representing that arrangement with a symbol, and then using that symbol as an element in a yet more elaborate configuration. This capability takes place in a brain structure called the neocortex, which in humans has achieved a threshold of sophistication and capacity such that we are able to call these patterns ideas. Through an unending recursive process, we are capable of building ideas that are ever more complex. We call this vast array of recursively linked ideas knowledge. Only Homo sapiens have a knowledge base that itself evolves, grows exponentially, and is passed down from one generation to another. Our brains gave rise to yet another level of abstraction, in that we have used the intelligence of our brains plus one other enabling factor, an opposable appendage, the thumb, to manipulate the environment to build tools. These tools represented a new form of evolution, as neurology gave rise to technology. It is only because of our tools that our knowledge base has been able to grow without limit. Our first invention was the story, spoken language that enabled us to represent ideas with distinct utterances. With the subsequent invention of written language, we developed distinct shapes to symbolize our ideas. Libraries of written language vastly extended the ability of our unaided brains to retain and extend our knowledge base of recursively structured ideas. There is some debate as to whether other species, such as chimpanzees, have the ability to express hierarchical ideas in language. Chimps are capable of learning a limited set of sign language symbols, which they can use to communicate with human trainers. It is clear, however, that there are distinct limits to the complexity of the knowledge structures with which chimps are capable of dealing. The sentences that they can express are limited to specific simple noun-verb sequences, and are not capable of the indefinite expansion of complexity characteristic of humans. For an entertaining example of the complexity of human-generated language, just read one of the spectacular multi-page length sentences in a Gabriel Garcia Marquez story or novel. His 6-page story, The Last Voyage of the Ghost, is a single sentence and works quite well in both Spanish and the English translation. The primary idea in my 3 previous books on technology, The Age of Intelligent Machines, written in the 1980s and published in 1989, The Age of Spiritual Machines, written in the mid to late 1990s and published in 1999, and The Singularity Is Near, written in the early 2000s and published in 2005, is that an evolutionary process inherently accelerates as a result of its increasing levels of abstraction, and that its products grow exponentially in complexity and capability. I call this phenomenon the law of accelerating returns, LOAR, and it pertains to both biological and technological evolution. The most dramatic example of the LOAR is the remarkably predictable exponential growth in the capacity and price/performance of information technologies. The evolutionary process of technology led invariably to the computer, which has, in turn, enabled a vast expansion of our knowledge base, permitting extensive links from one area of knowledge to another. The web is itself a powerful and apt example of the ability of a hierarchical system to encompass a vast array of knowledge while preserving its inherent structure. The world itself is inherently hierarchical. Trees contain branches. Branches contain leaves. Leaves contain veins. Buildings contain floors. Floors contain rooms. Rooms contain doorways, windows, walls, and floors. We have also developed tools that are now enabling us to understand our own biology in precise information terms. We are rapidly reverse engineering the information processes that underlie biology, including that of our brains. We now possess the object code of life in the form of the human genome, an achievement that was itself an outstanding example of exponential growth, in that the amount of genetic data the world has sequenced